Hello, I'm Kim Sauer at the EIPC conference in Munich. I'm joined by Martin Cotton from Ventec. Martin, thank you very much. Good morning. Thank you for being here. And you're going to be on stage in about half an hour's time,
yes, about half an hour,
presenting. Let's talk about the theme of your presentation. So you're talking about IMS,
yes.
Insulated Metal Substrates, and you're talking about the solution that gives us thermal issues. Can we just focus on the issues first, and then look at how IMS solves that?
Yeah. One of the things I'm trying to look at in my presentation is what kind of things we're looking at from metal. You know, that's the thing we're dealing with. You know, it's all about some kind of metallic substance and its thermal properties, etc. And so, using my design hat, I was sitting there looking at it and going, what are the things related to coining?
So you're really saying that you need to come in on the design stage already and consider IMS as a solution for multiple issues that you might have going forward in multiple industries or multiple applications.
Yeah, I mean, if you look at a simple LED solution, it's pretty simple. It's got copper, dielectric, aluminium or copper on top, and you can use it in a flex system if you like or not. But what happens if you want to use multiple levels of that? What happens if you really want to take temperature out of a board? You know, like the old copper in bar copper solution for the avionics industry. Well, that's a real brute of a solution, right? But okay, there's more subtle to it. You can use heavy copper combinations, for example. You can use coining on something specifically quite hot and connect it to an IMS system. You know, so you've got a coin, IMS, multiple heavy copper layers. So the combinations of these things. What I haven't touched on is I haven't touched on any exotic laminates, because they are quite specialist, and obviously when you get to specialisms, it becomes more expensive. Now, they do have a niche market. You know, don't get me wrong, they've always got that position. The thrust we're trying to do is, what are the normal solutions that are available for specifically complex problems, but they're using normal materials, like more normality. Because if you go into any procurement place or any design shop around the world, any OEM, as soon as you come out that envelope of what they know is cost effective, they don't want to talk to you. They go, yes, we know your material is wonderful, but, you know, now sometimes those solutions with a bit of value analysis with exotic materials can bring you back into line. But not many companies do it. Talk, don't walk the walk.
But they still have to look at that long-term cost of the material that they're using, and you know, the reliability issue, and you know, maybe using that sort of solution has a much better reliability, and therefore not less waste and failure.
It is.
So it's to consider those issues as well.
Yeah, it's a huge. See, I think. Yeah, IMS has been around for a long time. I mean, the printed circuit board industry has been plating great chunks of copper to a printed circuit board for as long as I can remember, right? But now it's IMS.
Now, the buzzword, the next big thing.
But there are significant differences between the days. You know, in the old FR4 days, where FR4 was FR4, you would have the real brute of a solution to solve something which was quite delicate and quite sophisticated, if you like. Now you've got the solution of IMS, because you can tailor the particular resin system for certain conductivity levels and things like this. It becomes more of an elegant solution. So, with elegant solutions, you need more design input. You don't have to bash your way through this thing. You know, a fan is a bashing your way through. You know your PC at home. You've got a monster fan in there somewhere, right? Or a heat pipe or something like this. My PC has got heat pipes, dedicated fans, you name it on it, right?
Mine's got fans and I hear them, going off. I think I'm taking off somewhere.
Yeah.
It's very much like being in a plane.
Yeah, and it's a brute of an idea, and it works. Okay, and it's relatively cheap, but the side effects is all those noise things and space limitations. So the beauty about IMS, as we know it currently, is that it has the objective of reducing the amount of space being used. It has lots of fluidic ideas associated with it, which you can then use a different, more sophisticated methodology of design, stroke for solutions, not just a single idea.
Which then also fits in with the trend of miniaturization, complexity of the PCB, and those space constraints that we're in.
Yeah, I mean, the key thing here as well is that we've got 25 minutes, and I'll be bashing through it. You know, it's going to be a lot of stuff, and I won't be able to put everything out there, because it's really, I'm asking the question to the audience, saying, you know, have you looked at this as an alternative, as well as the materials that we in Ventec offer? You know, have you looked at the constant solutions available by using multiple choices, you know, combinations even, you know, and as a material supplier, we can help in the selection of all those parts to enable true value analysis. Value engineering to take place at the design stroke engineering level. What was interesting, I just saw one presentation a few moments ago, and design was always the afterthought. Really, it should be involved right up front. Even in the way they were presenting that thing. Not an issue on the particular persons presenting, but it's a reflection of the industry as a whole, that they don't allow designers even in their choice at the front. And that could be a critical decision that someone down later down the line has to solve another set of problems which could have been designed out right at the beginning.
Perfect. Well, I won't hold you up any longer. You've got to get into the zone.
Yeah, got to get into the zone. I'm not there yet.
So good luck with that. Nice chatting to you.
Thank you, Tim. Thank you very much.
Thank you.
Thank you for your help.